Hello. Hello. Hello, can you hear me?
Yes, sir. Yes.
Okay, hi, hi. How are you?
Fine.
So, so I'll start. It's already 3:20. So uh, today I'll go through assignments of week 5 and week 6. Have you tried these assignments, or have you gone through?
Your voice is not proper, properly coming. It's very low.
Slow? Okay. Let me check.
Yeah. Yes.
Hello. Hello.
Yeah.
Hello.
Now
Hello.
it's audible.
Okay. Okay. So have you gone through the assignments? Have you tried doing the assignments?
Yeah, actually, I missed the week 6 assignment.
Week
Rather than
six.
that, it was all good.
Week 5. Have
But
you
actually,
tried week 5?
yeah, I have tried week 5, but week 6, I actually missed this one.
Okay. So I'll try. I'll do because I didn't do week 5 last time. So I'll go through it. So can you you'll have to communicate with me what kind of answer you have got. So the let's come to the question one. So it says which of the following properties are not consistent with a random walk.
Yeah, just 1 minute.
Huh. First one says number of dimensions should be 1. Then
Yeah, that may not, this property can be, but we cannot say that it's not consistent. The dimension can be one, but it should not be one. So this is not a
so yeah,
consistent one.
so it can be 2 3 also, right?
Yeah,
So this is now the next one, the steps should be independent. So is it correct?
yeah, that is correct.
Okay.
That can be independent based on because they don't have any biasness towards the direction, so it can be independent.
The next one, probability of
Yeah,
stepping in each
so
direction
correct.
should be equal.
That's also correct.
And the last one,
That seems it seems correct that distance is means partially correct but not completely correct.
partially correct means
Since certain times it can happen, but certain times it cannot happen.
distance move in an average proportional to time. So do you remember what was the distance uh,
Yeah,
moved
that
by?
was 0.
Yes, so it was 0. So it is not
Yeah, but
proportional to time,
okay.
right?
Yeah,
So
so this is also correct.
this both of them can be the correct answer, right?
Yeah,
So next one, you tell me how to solve it. I'll solve it. Okay. So if the step
yeah.
size is 100 nanometer, so first you know the step size in 100 nanometer in every 1 second. What is the diffusion coefficient? So what is the D? Okay. So how do we proceed?
Yeah, first, I would convert that into the step size. Consider step size to be 100 nanometer. Then I would try to convert it into the meter first.
So meter per second. This is right. Nanometer per
Yeah,
meter.
100 into 10 meter. Yeah,
Yes. So do you remember the this
formula.
equation? Something like a tau by 2 was correct, right? What was the formula? Do
Yeah.
you remember?
Yeah, I forgot that formula.
Okay, so if you go to week 5, if you remember this, we have derived.
Yeah, we have to write that formula.
Where is it? Yes, this one. Tau delta square by 2, right? So tau is the time to take one step, delta is the step size, right?
Yeah,
So so tau a square by 2, let's say write in the notation delta square, delta is the step size. So if you put all of them, so tau is the 1 second, so every 1 second it moves
yeah,
100
we are
nanometer.
100 nanometer step size.
Whole square by 2 second times meter square by 2. So this will be the unit and this is the value.
Yeah,
So I think around shall I calculate this?
yeah, it would be 10 to the power minus 14. Yeah.
Yeah.
It's zero point 0.5, and when we do it, it would be 0.005, 0.05 nanometer square. It would be 10 to the power.
Yeah, something like that. Okay.
Yeah,
So if a typical protein in E. coli cell has a diffusion coefficient of 100 micrometers per second, 100 micrometers per square per second, what is the time it takes to cross the cell on an average? Assume the number is only returning. Take the standard E. coli size as discussed in class. So do you remember what is standard E. coli
yeah.
size?
If we consider an E. coli, its size is around 1 μm, means 1 micrometer.
Yeah. So how do you calculate? So let's say you have 1 micrometer size of E. coli and some protein with this size,
Yeah,
this coefficient is doing a random walk. So how what time will take? Let's say it started here and doing a random walk and going there. So what time will what how much time it will take? So how will you proceed?
So first of all, we are given the distance. So
Yes.
no, we are given the diffusion constant. So based on diffusion constant, I would like to get the answer for the distance, which is like 1 mu meter. So using that distance, I would try to proceed with the formula and using to calculate it with the time.
Do you remember the formula?
Yeah,
Do you remember the formula for this?
yeah. It was sigma n square n. Okay,
Sigma
two
n
d
square. Then what is sigma?
summation.
Oh, summation n square. Okay. Now, do you remember this mean square displacement?
Yeah, we are actually doing the square of the whole thing, then calculating the coefficient, remaining coefficient, because the answer with the squares was getting zero, but the coefficients of both the factors were getting certain value.
Yes. So this had a certain value, right? Remember this calculation from the previous week 5.
That's
So we had
yeah.
this, right? 2 dt. So if you put xt to be 1 micrometer, you can calculate t, right?
Yeah.
But there is a catch here. So what you should like actually this formula comes from 1D random walk. 1D.
But here we are considering 2D random
Yes.
walk.
So for 2D, so xt square average is 2dt. Similarly, in y direction, yt square average will be also 2dt, right? Because there is no bias in any direction. So total average, like let's say r square, will be 4dt. Now you calculate t as r square by 4d. Now r square, in place of r square, it put 1 micrometer square by 4 times d value, whatever 100 micrometer square per second. You put it and you will have something 0.25, and you put the nearest one here. Whatever the nearest answer, you just put it. Fine.
Yeah.
So next is, why do we consider velocity to be a term that is inappropriate in the context of random walk and diffusive particles undergo? Okay, so this is not numerical question, it's like more like conceptual problem. So here so in the equation, velocity is distance by time. The distance traveled is 0 on an average. That's the first option. The velocity is not constant and depends on time window chosen. Velocity of diffusion is a constant. Nature of stepping of particles undergoing diffusion is random. So which one do you think will be the correct answer?
I think the nature of the stepping particle undergoing diffusion is random, because when we consider the velocity, we give a direction to it. So speed is the thing which we calculate for non-directional quantities, but when we consider the velocity, we are having certain direction in mind. So if we consider the motion to be random, then it might not get properly specified here.
I couldn't understand it properly. Mm,
Yeah, so whenever we want to calculate the velocity, we are always having certain direction with associated with the velocity. Because the motion is the random, every time we are getting a random, means a random direction with random velocity. So that
hmm.
could be the term, which is why we are not using velocity.
Yes, so they don't have like for short range, they have a directed motion velocity with a particular direction and
Yeah.
magnitude, but overall they don't have any velocity. It's just random motion, like or not consistent with time. So this is actually velocity of diffusion. So velocity of diffusion is not definable because on average xt is comes to 0. Now dx
Yeah.
dt average will also be 0, so there is no velocity basically, right?
So
But
it would be the proper answer.
so this also can be correct answer, this also can be correct answer, but this is not constant, this is not correct because it is constant depend on
Yeah.
time window chosen. So if in any time window, like let's say this is the whole path, for every
Chosen. Yeah. For very short distance, it
yeah
can
it
be.
can be constant, yeah. So a or d anything can be correct, I think. A might be like if it I think it was a multiple like correct answer type, right?
Yeah. To,
Hmm.
yeah, I think so. For the D option.
Mm-hmm. Your voice is like have some noise around.
Sorry, I was saying that for option B, it was showing partially correct if I remember correctly.
Option B.
Current result.
Option B.
Yeah, option D.
Okay, D. Yeah, okay. Yeah,
It was showing partially correct.
okay. Yeah. These had uh, multiple answers. This set had multiple
Yeah,
answers. Hmm.
that is why.
So five. Question number five. So what is the run and tumble
Yes,
motion of
so
bacterial motility or
I
observed?
just also wanted to clarify one more thing.
Huh.
In exams, can we use the paper and pen for doing such calculations of numericals?
Yeah, it
Because
will
I
be.
could not find that answer because they were saying that on-screen calculator would be provided, but pen and paper would be allowed for those people which are submitted to be online.
Is
So would that would
will
be given to us?
it will be an online exam, right?
Yeah.
So there will be multiple choice questions.
Okay, oh, that's clear, but just like there are numericals, so would we be given rough to do the rough, or do we have pen or paper facility?
Uh, I think you can use um, your own rough paper, right?
Okay,
No,
because they have not told that. So just that.
so see, I'm not sure, but it is an online exam. Like from you will be giving the exam from your home, right?
No, it's mentioning that having a center.
There is a center.
Yeah,
Oh,
they are mentioning every city have some center.
okay. Then they will provide. If you require, they will provide.
Okay.
Yeah. Hmm. Okay. Okay.
Yeah.
So
Yeah, you can continue.
assignment 5 is what is the run and tumble motion of bacterial motility that was observed in very early studies due to in terms of random walks. So run and tumble, you remember what was run and tumble?
Yeah. So that was that whenever bacteria starts to move,
Yes.
it was showing a straight line for certain times. Then whenever it comes in contact with certain medium, then it starts to showing a vibrating motion, and then certainly changes the direction, and then again goes forward for certain straight direction, and then again might show some vibration.
Hmm.
That kind of motion.
So this kind of structure is there, right? Bacteria, like it's like a rod, then there is
Yeah.
flagella. So this rotates and this. So what happens is it goes for a in a direction for a particular amount of time, then for any some reason it just changes its direction randomly, then goes for some time in a particular direction, then again changes motion random the direction of motion randomly. So which one will be the correct? So runs correspond to the directed transport, while tumble corresponds to a random one. That's correct, right?
Yeah.
Okay, fine. So next is week 6 assignment 6. So you said you haven't tried this, right?
Yeah, Week 6 I had not tried.
Hmm. Okay, so let's.
Sorry, maybe Week 7 was the last assignment was of Week 7, no,
Week 7.
Saturday.
Last assignment week
Sorry,
7.
Wednesday.
Yes, yes, week 7.
Wednesday actually I was not able to complete it on time, so
Mm-hmm.
I missed that. So again Thursday when I saw the assignment was 7 marks, the marks was given 1000. So that I
Oh,
don't
okay.
remember that it was either assignment 7 or 6.
Oh, that will be 7. So
Okay.
7
Yeah.
we haven't discussed 7. I'll do it in the next class. Week 7.
Yeah, yeah.
Hmm.
So this will be definitely a 7 6 I would have tried.
Hmm, 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 hmm. So okay, so actually we are going one class late. So I wanted to take an extra class, but there are some like mm, we in weekdays people are saying that they have like office or something. So I couldn't take in weekdays. So in weekend I planned, but there was not much students. So I will take one extra class in
Yeah.
because you are only joining. So can you tell me which will be preferable for you, like any weekday or something? Is can you manage time,
Uh,
or I can take like on 1 hour
yeah,
personal
I can also manage time on Monday. Maybe this Monday.
this Monday?
Yeah, I can manage time.
Okay. So there is no pressure. Like if not, then what I'll do, I'll take on class 1 hour and upload the video.
No, no, that's possible. Monday I can. Monday and Tuesday also I have time, so I can do that.
Okay. Okay. So that can be done because it's getting
So
late.
if
So
kept on Tuesday, then I would also go through the Week 7 content and see if there are certain doubts from my side. Or I will just overgo for certain topics which I have doubts, so that we'll also discuss. So if Tuesday, then it's proper.
yeah, to Tuesday will be I think better also because I will have some time to for me like I will have to go through it also.
Okay, okay.
So
So can we keep on Tuesday or
okay, okay.
any other?
Tuesday I'll week 7 Tuesday 3 p.m. to 5 p.m. Okay, if any changes, I will let you know. You share your email with me. Okay.
Yeah, okay, I will share my email. And also another thing, last time you have given the email, but I did not have any doubts, so I did not mail on that part.
No, no, it's fine. You don't have to like. You just send me a random email like a hi or something, so that I get your email. So if some class is changing
Okay,
or not, I'll can let you know. Okay.
okay, yeah, because I did not have doubts, so I not email, right?
No, no, it's fine.
So I just wanted also to clarify that point.
Okay, okay,
Yeah, I
fine.
will send a random email regarding this.
Okay. So so have you solved this one?
Yeah,
So what is how many macromolecules are present in a cell where the average spacing is 100 nanometer and the cell volume is 1 meter cube? So it says cell volume. Assume the proteins are point particles. So proteins are point particle. You have to assume for this and arranged in a
Yeah.
regular cubic lattice. So it looks like this. So here is a protein. Here is a protein. So how will I solve it?
So first of all, we will try with the method of finding the cube diameter. Sorry, cubic volume problem, and that we would solve for the NaCl structure and all those structures.
Hmm, hmm,
We
hmm,
would try the same method here.
hmm. So what is the cube volume?
That is L cube.
Sorry, this is 100 nanometer. So it is L cube. So 100 nanometer
Yeah.
cube. So what is the fraction? It's simple, 100 nanometer cube by 1 micrometer cube. Right?
So that would be approx.
So I wrote opposite. Sorry. So
Yeah, it would be become 10 to the power minus 14 or around 6 answer was getting.
10 to the power 3.
Yeah, yeah.
So can you did you solve it? This problem? This is related to this problem, macromolecular crowding. So
One problem.
mhm. So what this thing does, polyethylene glycol, it helps in multiple ways. First is it crowds the enzymes. So and increases sometimes increases the viscosity of the media. Okay. So Vmax is the velocity. So what happens is ATP based activity when they are crowded, it decreases the velocity of this. Yeah,
Velocity.
and also this is affinity. Km is the affinity. So whenever there is a crowding, it can easily find the enzymes, and so it can easily find the protein. So it will also increase the affinity.
Yeah.
So B and C are the answers. So how many dimer tubulin are added if a microtubule grows by 1 micrometer? Did you solve
So
it?
approx 120, approx 250.
How did you reach there?
Yeah, I tried to search it on the internet to get the concept.
Okay, so there is this dimer size you found, right?
Yeah.
Yes. So if you find the like dimer size, then microtable and you just divide it, like how many, like for one dimer size you get the size of the dimer.
And then divide with the whole 1 meter and then I will get the answer.
Yes, either 125 or 250. I don't exactly remember it, but it will be around that.
Yeah.
Could you solve this? much force is required to
So here
expand?
we will just calculate the Young modulus formula because we are given the stiffness.
Yes, stiffness is 2.3 Newton per meter. So it's easy, like you can, if you like, do this kx, let's say k delta x. So this is the force, how much force you want to calculate.
Yeah,
5 nanometer is the extension, and stiffness is 2.3 Newton per meter. So this is 2.3 Newton per meter times 5 nanometer. So you can calculate like 11.5 times 10 to the power minus 9 Newton. So 11.5 nanonewton. Fine.
yeah,
Okay. So this one is an easy question. Young's modulus of different cellular materials vary between values. So it is mostly like if you go through the lectures or you can find it on internet. I think two options are there. Gelatins, this one, and see these two and these two are same. Cartilage is higher than gelatin cells, and collagen lies between here, somewhere here. Collagen. So A and B both are correct actually.
yeah,
Fine.
yeah.
So did you get this right?
I think so. I had in search for the internet.
It's assignments you can do that actually. Yeah,
Yeah,
people do assignments. So that was all for today, because it is supposed to be 2 hours, but I think it's done. So you already solved it. That's why sometimes I have to explain some problems because people haven't solved it or they didn't go through the lectures. But most of the time, if you go through the lectures, you can solve all the problems, or if you try, you can do it by your own. Right?
yeah.
Okay, then that was
Okay.
all. Then you drop me an email and I will try to fix a time in Tuesday.
Yeah. Okay.
Sure. Okay, Harsh. Nice to meet you.
Bye.
Bye.
form a higher order structure called the solenoid or chromatin fiber, which